This project started, or work on this project started way back when BMCC decided that they needed to have writing intensive classes for students as part of their graduation requirement. So I chose to do a writing intensive class both in statistics and in discrete mathematics, which are some of the courses I teach at BMCC. It has always been a concern to me that Africa, or Africa south of the Sahara, is left out of the textbooks in terms of illustrations that can help students understand certain mathematics concepts, even though math is all around us. When you look at certain things, even from the African cultural perspective, you can see where certain mathematical concepts come into play. I decided, well, if I am going to develop a writing intensive course in discrete mathematics, this was a unique opportunity to bring forward some of the things from my cultural perspective to the classroom so that students could see how some of these things intersect with their lives, given that BMCC has a large African American population and a large international student population, of which you have a large number of students that also come from the continent of Africa itself.
Math, as a student and as a general student, everybody will learn just normal basic arithmetic and everything. You learn a cultural enriching aspect to it. You learn to realize all those things you knew as a young child back home, and you're able to see patterns and putting aspects what you can bring out from all those things and inspire other people to learn from you.
I played around with a few areas, one being games, because people play games a lot, and board games are very popular in Africa. And there's a board game popularly known as the Mancala game, but it has different names in different places around the world. It's played almost around the world because it was transmitted in three ways: through commerce, slavery, and Islam. So you find that board game played all over the world, and it is very, very strategic. As highly strategic as chess. It can be made as simple as you want, and it involves a lot of different mathematical connections.
In class, in Math 200 with Professor Agu, I learned the Mancala game can work in probability and sets and teach you ways you can actually play this game and improve your memory and your thinking. It's almost a game on the same level as chess. It's just the same kind of level, and you're able to, like, most of the time I played it back home and I didn't realize. I just played it with luck. If I won, I won. That was it. Right after this class, I can go and I can play this game by actually thinking before I make my moves. The Mancala game has an influence on computer programming and algorithms, because you're able to write algorithms that have to do with probabilities and the number of steps it might take to win games, and greatest common, maybe the greatest numbers, most moves you can actually make and least moves you can make in that kind of game.
And what I have here is a Mancala game,
You can just show it.
which can be developed out of things that don't cost money. So most of the things that we're doing in class, part of this project is also to find ways in which schools or educational centers that are poor or don't have resources can easily introduce mathematics to their students in simplistic ways, using manipulatives that cost no money that they can find right there around them. And this is a doll that has been created as a replica of an African woman in mathematics, but this doll shows some vertex edge graphs in the woman's life, like a triangular arrangement. That's a wheel right there, and that's a P3 path. What this does is to give students an appreciation of diversity, I think, and to help them see that mathematics is all around them, even in the necklace that I am wearing right now, because this is also another activity that they sometimes have to do, which is create a necklace that is a cycle, and they actually might create two, one that is an even cycle and one that's an odd cycle, and they color the necklace for its chromatic number, and they actually present their necklace in the class, so they see how jewelry even connects to vertex edge graphs.
I learned a lot more, that I could actually tell somebody back home that they have a lot of cultural aspects to mathematics back home, and they'll look at things that they could throw away and actually learn from it, make toys from it, make education from it, and teach other people, rather than expect me to like import all the products from the US. I'll teach them how to make the things that they already have right there.